Okay, guys. Nice. So, shall we start the session today then? So, are you able to see the screen? So, today I am starting with machine learning algorithms. Yeah. So, let's start with machine learning algorithms today, guys. So, before starting my machine learning algorithms, I would like you guys to ask what are all the different kinds of techniques that are there in, different kinds of learnings that are there in uh, machine learning or deep learning or any artificial intelligence product life cycle. Different kinds of machine learning techniques. That's really good, Shivakumar. Those are regression, classification, clustering. Those are the different kinds of problem statements that will be there in machine learning. I'm talking about the techniques, learning techniques. Okay, different kinds of learnings. Yes, that is good, Ravalika. Supervised, unsupervised, and reinforcement. Right? So these are the different kinds of learnings that a machine learning algorithm or any artificial intelligence algorithm will have. Right? So what is the difference between supervised and unsupervised? Yeah. So in supervised learning, you will have the definite data for the machine for learning. But in unsupervised, you'll not have a defined data. It will have a raw data from where the machine or our algorithm will make that into groups. Yes. And this supervised learning is used for prediction, the future outcome. But with the help of the unsupervised learning, you cannot see the future outcome. So again, in supervised learning, we'll have classification as well as regression. So whenever you find the numerical value as the output, then you can consider that as the regression problem. If suppose you have any classification kind of things like ones or zeros or any categories, then those comes under classification problem, right? So today in this session I'll be dealing with regression. So the first type of the machine learning, supervised machine learning technique, which is regression. So now tell me, what do you understand by regression? What is regression? Regression is nothing but a kind of statistical relation between inputs as well as outputs. So if suppose there is any change in the inputs, then there will be the change in the particular value of the output. So that output is used for prediction. Okay, so whenever the predicted column is numerical, then you can consider that as a regression kind of problem. But when it comes to the definition, regression is nothing but a statistical relationship between the variables. All right. So in this regression, we have different algorithms, out of which we will be dealing with linear regression, multilinear regression, polynomial linear regression, uh, decision tree regression, random forest regression. So these are the 5 algorithms that we gonna deal in this internship. So without any delay, let's get started. What do you understand by linear regression? First, suppose your independent variable is plotted on x and your dependent variable is plotted on y. If suppose as x is increasing, then y is also increasing. Then the relationship between dependent variable and independent variable will be a positive regression line. Positive regression line. If suppose the independent variable is increasing but the dependent variable is decreasing, then you consider that as a negative regression line. So these are the different kinds of regression, linear regression techniques that we have. All right. So what is this line? How is it formed? Everything will be explained within few minutes. All right. So if suppose, let's see, you have independent variable and dependent variable and you have a positive line over here. So this line is formed with the help of an equation which is y is equal to mx plus c. So can you please tell me, where did you see this equation? Have you ever come across this equation? Yeah, where did you see in that equation? What is that equation? This is the equation of a straight line passing through some of the coordinates, right? So it is the equation of a line. So how do you get this equation of a line? By substituting the values in this equation. So I hope everyone have the idea of coordinate geometry, right? So in that we had some sort of graphs. In those graphs we used to plot all these kind of the equation of slope, parabola, hyperbola, all those things we have implemented our engineering or your intermediate, right? So this is the equation. So our linear equation, linear regression depends on the equation of a line. So let's see what are these variables called as. So here y is nothing but called as dependent variable. Y is nothing but called as dependent variable. A naught is nothing but a constant, and then a1 is a coefficient and x is the independent variable. So as we say that m is slope of the coordinates, here a1 is also the slope of the coordinates between y as well as x. All right, so here a naught is some sort of the constant. Now with the help of this equation, we will be building a best fit line for the data in linear regression. So if I tell you the practical implementation, then you will understand it in a better way. All right. So now, how can you calculate all the values of a naught, m, etc.? So if you want to calculate the value of c, then you have to replace y with mean of y and x with mean of x. And m anyhow we will be calculating with the formula. So what is the formula of a slope, guys? What is the formula of a slope? If you have coordinates, so that is y2 minus y1 divided by x2 minus x1. Yes. So with the help of same formula, we will be calculating the m. So once we get the m, we will be substituting mean of y, mean of x in the equation, so that we get the constant value c. So here constant value c is nothing but the a naught that I have showcased before. Okay. So let's solve these things with some sort of examples. So here, as I already told you, x is mean of independent variable, y is mean of dependent variable, m is slope of a line, c is constant. So x minus x bar into y minus y bar divided by x minus x bar whole square. So this formula and whatever the formula you said is same. So whenever you just write it as x minus x bar into x minus x bar, one gets cancelled. So it becomes y minus y bar divided by x minus x bar. But here we have some sort of summation, sigma. So let's see what is this sigma with some sort of example. All right. So let's say we have x and y. Okay. So I'll just do the same thing in the Word document. So let's suppose I have two columns. So X is nothing but the experience that a candidate has, and Y is nothing but the salary that the candidate will get. So I'll take the same here. So 1 year, 2 year, 3 years, 4 years, 5 years. So here I say experience is 1 year, 2 year, 3 year, 4 years, and 5 years. And then the salary, let's suppose 3 lakhs, 4 lakhs, 2 lakhs, 4 lakhs, 5 lakhs. 3 lakhs, 4 lakhs, 2 lakhs, 4 lakhs, 5 lakhs, let's suppose. So here we are predicting the salary of a person based on the experience. So now our equation will become salary is equal to slope of sal and experience into experience plus constant. All right. So this is how my equation became. So here y is nothing but salary, x is nothing but your experience, and slope anyhow we have to calculate, and you already have a constant variable a naught. We have to calculate the constant variable as well. So first, before calculating the constant variable, first of all you have to calculate the slope. All right. So what is the slope that we have? M is equal to x2 minus x1 divided by y2 minus y1. So this can be represented as x minus x bar divided by y minus y bar. Y minus y bar, which is equal to value of x minus mean of x divided by value of y divided by mean of y. So here value of x is nothing but what? 1. All right? Yes or no? So the first value, 1 minus, what is the mean of x? 2, 3, 3, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 by, value of y minus. So 15 by 5, which is 3, right? 1 minus 3 divided by 3 minus, what is the mean of y? Mean of y, guys. Mean of y is 18. Mean of y, salary. How do you get 9, guys? 4 plus 3, 7. 7 plus 2, 9. 9 plus 4, 13. 13 plus 5, 18. 18 divided by 5. What is it? It is 3.6. So 3 minus 3.6. 3 minus 3.6. So you will get a value. What is the value of this? What is the value of that, guys? So should I even teach you the mathematics? So something like that we get. So if suppose if we put that in this formula, you can see. So this is x minus x bar is minus 2, y minus y bar is 0.6, x minus x bar whole square is 4, x minus x bar, y minus y bar is 1.2. All right. So whenever you sum all those things, you got 10 and 4. So if suppose you put that in the equation, which is like this, then we got 4 by 10, which is 0.4. So for every value, you have to calculate. For each and every value, you have to calculate. So here you have calculated it for x, the first value, plus the slope of second row, plus the slope of third row, plus the slope of fourth row, plus the slope of fifth row, and so on. Now I got m is equal to 0.4. Now let's substitute this formula in the equation. So what is y here? 3.6 mean is equal to 0.4 into, what is the x value? Mean of x is 3 plus c. So 3.6 is equal to 3.6 minus 1.2 is equal to c. Yes? 2.4 is equal to c. Now put the value of c and m in the equation. Then you get salary is equal to 0.4 experience plus 2.4. This is what the equation that I get. So now I have calculated my slope of the calculate the equation of a slope for my x and y. Now our intention is to check whether this is the correct equation of the line to predict the data or not. Whether is this the correct equation of the line to predict the data or not. So for that, what we do is we already have some sort of x, right? Now what I do, I will put x values in the equation which I have formed. So now salary is equal to, what is experience? 1 into 0.4 plus 2.4. So what is the value of this case? What is the value of y here? What is the value of y? So I got is equal to 2.8. Fine. But what is the actual value? It is 3. So let's suppose predicted value is equal to 2.8 and actual value is equal to 3. Put it aside. Now, calculate y for the next equation, the next one. What would be the salary of the next? Guys, tell me. The next value. What is the next value? 2. Salary is equal to 2 into 0.4 plus 2.4. What is the value, guys? It is 3.2. So prediction value is 3.2 and actual value is what? 4. Actual value is 4. Now same calculate for the third row. That is 3.6. Spread value is 3.6. Actual value is, what is the actual value that we have? 2. Now, do that for the next line. Do that for the next line. It is 4. So now I give it as 4. So the predicted value is, spread value is 4 and actual value is 5. Now do that for the next line. 5 into 0.4 plus 0.4, it is 4.4. Spread value is 4.4, but actual is 5. So here this is the actual value is 4 only. So now what I will do is I will plot the graph between the x values, predicted value, as well as the y value. All right. Now what I do, I'll just plot a graph. Y, x, x, y actual and y prediction. Okay. So y has 1, 2, 3, 4, 5. Here also 1, 2, 3, 4, 5. So for x is equal to 1, what is the actual value? For x is equal to 1, what is the actual value? For x is equal to 1, actual value is 3. What is the predicted value? 2.85. So for 2, what is the actual value? For 2, the actual value is 4. What is the predicted value? 3.2. Good. So for 3, what is the actual value? It is 2. What is the predicted value? 3.6. Now for 4, what is the actual value? 4. Predicted value is also 4. What is the actual value for 5? What is the predicted value? 4.4. Now this is your equation of line. Now you have to check whether this line is correct line or not. So in order to check whether this is the correct line or not, first of all you have to calculate the error. So how can you get the error? Like whenever you differentiate between the actual value and predicted value, right? Then you will say what is the error that you got. Do you agree or not? Do you agree or not, guys? Error is nothing but difference of the prediction and actual. Do you agree or not, guys? So how do we calculate? We just say spread minus actual plus spread minus actual plus, so how many values we have? 5 values, yes or no? Minus plus spread minus actual. So we have 5 x's. So you'll have 5 prediction values and 5 actual values. Plus spread minus actual plus spread minus actual. So now here you just put 2.8 minus 3 plus 3.2 minus 4 plus 3.6 minus 4 plus, sorry, 3.6 minus 2, right? 3.6 minus 2 plus 4 minus 4 plus 4.4 minus 5. Right? So now you get some sort of error. Let's suppose the error is, can you please say what is the error, guys? Can you please tell that? 2.8 minus 3 plus 3.2. We got something like 0.1 or so. We'll get 0.1 or so. Yes, now you got the error. And in machine learning, the error is calculated with the help of y minus y, sum of y minus y whole square. Sum of y minus y whole square. So I got it as 0.1. I don't know why you're getting it as 0.0. Okay, fine. Okay, I've put it as 4.5. Fine. I got it as 0. Fine. So if suppose the error is 0, then you can say that it is a best fit line. But for suppose if you don't get a error as 0, but you got the error as something like 2.6 or something. So at that time, what you do is you will just change the slope. You will just change the slope. So initially you will be calculating the slope with the help of this equation, and you got the equation as 0.4. Right now what I do, I'll just take something like a learning rate of 0.1. So learning rate of 0.1 is nothing but slope should be increased with a rate of 0.1. So 0.4 plus 0.1 will be 0.5. Now whenever m is 0.5, your C value changes. Yes or no? Yes or no, guys? So what is the C value now we got? So you'll get it as 2.1. Yes. Now my equation will become salary is equal to 0.5 experience plus 2.1. Right now I got this equation. Now again I have to calculate all the things. So I have to say this equation. You have to put the equation and you have to calculate all the prediction value and actual value. Once you do it, again you'll get an error. Again you have to calculate the error and you get an error something like 2.7 or something else. Now again you shift the slope. Again do the whole process. Then again you get the error. Let's suppose it is 1.2. So out of these three iteration, you have the error of this line as small. So for suppose here the equation is y is equal to 0.8 plus 0.8 x plus 3.6. So let's suppose at this equation you got the error which is very less. So at that time you consider this equation as the perfect equation for predicting the value. All right. So that is nothing but called as the concept of gradient descent. So if you see here, whenever you calculate the error for each and every equation, whenever you say that the error is minimum, that equation is considered as the best fit equation. So if you see in the GIF, you can see that the slope is being changed. Okay, so the error, this learning rate will be based on the gradient descent, guys. For suppose if your slope is if your slope is like, for suppose you are increasing the slope, which is increasing the error, and that time you have to decrease the slope. If suppose you are decreasing the slope and you are getting the error as high, then you have to increase the slope. So it depends on the error only, and that will be taken care by the algorithm itself. But the process of calculating the minimum error is nothing but called as gradient descent. So first, if you see that the slope of an equation was over here, now after some iterations, your slope of equation got into the middle. Now this equation is considered as the best fit line. And in linear regression, you will have only two columns, which is one input column and the other is output column. So this is what linear regression is. Did you understand, guys? Did you understand the linear regression? If you have any doubts, you can ask me. So Pramod, did you understand the answer that I have told? I just now said for your question itself. So first suppose, again I'm telling, if suppose you have increased the slope. So I have just put it as 0.1 plus. Now what happened? Error became high. Then what you have to do? You have to subtract it. Whenever you, for suppose if you are subtracting, again your error is high. Then you have to add it. All right. So this is how your linear regression will take place. Did you understand the concept, guys, everyone? So while in the, did you understand the concept? If not, just let me know. Everyone. So I told machine learning uses statistical approaches like the mathematical formulas and all. So this linear regression is using equation of slope for predicting the future. So as a best fit line, our equation is formed. Now, if you give any new data to this equation, so here in that I have only 1 to 5 years of experience. Now you can apply it for 6 years, 7 years, 8 years, 9 years, and so on. Yes, do you agree? Can you apply the other things also to this so that it will predict the other values as well? Do you agree, guys? So this is the best equation that we got. And if suppose you want to predict the other values also, fine. So for 9 years, what is y? Same thing. So 0.8 into 9 plus 3.6. Then it becomes your y. So that gets trained and the data get plotted onto the graph. So again, it got trained on the 9 years also. So whichever the new data you give that gets trained on the new data as well. Understood, guys? So if you are fine with this, then I'll move on to the multilinear regression. Any doubts? Any doubts? So what is the concept of minimizing the error? What do you mean by gradient descent? If you have understood, tell me what do you understand by gradient descent? Guys, I'm asking you only, what is the concept of the gradient descent? Is only Srilekha and Sai Roshni in the class? Yes. So the process of minimizing the error, the concept which is under the minimizing of error is nothing but called as the gradient descent. So here you're calculating the mean square error, guys. Squared error. So here you're calculating the squared error. So like I have showed you the, here you have used squared error, right? Y minus y whole square. So you will have root mean square error, squared error, mean square error, everything will be there, but here we are using squared error. All right, this is squared error. Now, now let's get into the multilinear regression. So, can you please tell me what does this multilinear regression mean from the name? What does this name indicates? Multilinear means multilinear means many errors, more than two errors. What is this error again? Why this error came into the picture? Yeah, tell me the difference between linear equation and multilinear equation. What is the difference between linear equation and multilinear equation? So linear equation will have only single variable, but multilinear equation will have more than two variables. So if you have more than two variables, then you have to move on to the multilinear regression. So here also, whatever the gradient descent concept that we have used, the same thing will be used in multilinear regression also, but for the different values. So let's see how that equation will looks like. So as we have only one variable, in linear regression, we have just used y is equal to a naught plus mx, or y is equal to mx plus c. But in multilinear equation, it is not the criteria, it is not that it will only have one variable. It may have multiple. It may have two variables, it may have four variables, it may have 10 variables, and so on. So the equation that is for multilinear is nothing but y is equal to a naught plus a1 x1 plus a2 x2 plus a3 x3 and so on ai xi. So here x1 is nothing but the value of the input independent variable 1, x2 is independent variable 2, x3 is independent variable 3, and x4 is independent variable 4. And this a1 is nothing but the slope of x1 and y. a2, slope of x2 and y. a3, slope of x3 and y. ai or an, slope of an and y. And now this a naught will be calculated by replacing with the means of x and y. So if you see the notations, y is dependent variable, xi is independent variable, a naught is constant, ai is slope coefficients for each independent variable. All right. So now how do this perfect multilinear equation is created? The same phenomena goes even for the multilinear equation as well. So let's suppose I have some other columns also. So first suppose I have another x2, x3, right? So here also I have the values as 3, 4, 2, 1, 1, 2, 1, 3, 4, 2. Now the equation of multilinear will become like y is equal to a naught less a1 x1 plus a2 x2 plus a3 x3. Now a1 is equal to y minus y bar divided by x minus x bar. So what is the formula here in the equation? What is the formula of linear equation for slope? It is x minus x bar into y minus y bar divided by x minus x bar whole square. So the same thing we'll write here. X minus x bar into y minus y bar divided by x minus x bar whole square. All right. So here x is nothing but the value of x1, that is experience. So x1 minus x1 mean into y minus y mean divided by x minus x1 mean. So now I got a1 value. In the same way, I have to calculate the a2 value as well. So here a2 is nothing but x2 minus x2 mean y minus y mean into x2 minus x2 mean whole square. In the same way, you have to calculate the a3 as well. So a3 is equal to x3 minus x3 mean minus y mean into x3 minus x3 mean whole square. So now you got the value of a0, a1, a2, a3. So let's suppose a1 is nothing but 0.6. Let's suppose a2 is nothing but 0.8. a3 is nothing but 0.2. Let's suppose. Now your equation will become y is equal to a0 plus 0.6 x1 plus 0.8 x2 plus 0.2 x3. I'm just assuming, guys, just giving the random values. Fine. Now I got y. Now the main aim is to calculate y. So how do you, the main aim is to calculate a naught. So how do you calculate the a naught, mean of y? So let's suppose mean of y is 3.6 is minus 0.6 into x1. Let's suppose x1 value is, mean of x1 is 3, minus mean of x2 is 0.6 into mean of x1 is 3, minus 0.8 into, let's suppose it is 4. X2 is, mean of x2 is 4, let's suppose, plus 0.2 into mean of x3 is, let's suppose it is 3. Now you get the value of c or a naught. Let's suppose that is 4.6. Now the equation is y is equal to what is this a naught? 4.6. So now this is the equation of the multilinear problem. Now you have to calculate the predictions for all the values. So for x is, y is, for 1 3 2, what would be the salary? Then you will get y pred as well as y actual. Again for the second row also you'll get y pred and y actual. Again for the third one you also get y pred and y actual. Again for the fourth you'll get y pred and y actual. So based on this, again you have to calculate the mean square error. So which is the minimum error? Then that would become the perfect equation of the multilinear equation. But for linear equation, a straight line will be formed for linear equation. But for multilinear equation, if you have more than two values, a hyperplane will be formed. So before we just had a straight line, but here we have hyperplane. So for that hyperplane, again you have to calculate the y actual minus y pred minus y actual plus 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 and so on plus whole square. So until you get the value as minimum. So this, the multilinear regression is based on the following assumption. So there is a relationship between the dependent variables and the independent variables. The independent variables are not highly correlated with each other. So this is what about multilinear regression. So now do you have any, so whenever you replace it with a 3D dimension, this is how your multilinear equation will be. So first suppose this is the line between y and x1. This is the best line between x1 and y. Now whenever you just join these, then this becomes a hyperplane. So this is what about your multilinear regression. So do you have any doubts? If so, please ask me. So guys, understood multilinear equation? Understood the multilinear equation regression, guys? Guys, did you understand the multilinear regression? Guys, are you listening to the lecture or not? See guys, if you're not understanding, please let me know. Otherwise, you just ask me the doubts. I'll help you in understanding. If you don't respond to me back, then I'll not understand whether you're following me or not. Here also you'll get the error, ma'am. That's what I told, right? So vibrate y-axial, vibrate y-axial, vibrate y-axial, vibrate y-axial. You have to calculate the error, which is MSE, mean square error. You get error value. Now again change the slope. Change the slope of x1, change the slope of x2, change the slope of x3. Then you create another equation. So however we are changing the slopes in linear equation, in the same way you have to change, so that it becomes the perfect equation. All right. Same as linear, multilinear regression is same as linear regression, but the only difference is it has different, more than two independent variables, and it is formed up, hyperplane is formed between all the variables. That's it. Understood, guys? Yeah, I've just now stopped, sir. I'll start it whenever I again start the session. So shall we move on to the practical approach? Shall we move on to the practical approach, guys? Yes. So I'll be sending two data sets. I'll be sending two data sets. Please download both the data sets.